Alright, so now we have the hardware set up and you've got the firmware installed in your Arduino, so we are ready to write the VI. If you don't have the firmware installed in the Arduino, the VI is not going to work, so go back and keep hammering away on that task until you get it fixed, and let me know if you need any help. The VI will work without the hardware attached, the potentiometer. It'll just measure a random voltage, so you can test it out. But the potentiometer is pretty easy to connect, so you might as well. Alright, so I'm going to open up a basic LabView file here. So we've got the front panel on the left and the block diagram on the right. And I'm going to go through this from sort of the beginning. I want to measure the analog voltage on the Arduino and display it on the front panel. That's my goal. And then we'll get fancier as we go along. So this is just going to be the most basic way to do it. So the first thing I will do is I will put a display numeric indicator on my front panel, and that's where I'm going to display the voltage. And then I'm going to just try the most basics thing under Maker Hub, links, peripherals, analog, read. I can read an analog voltage, so I'm going to put that down. Analog read one channel looks good. And then it has all of these inputs and outputs, so I'm just going to find the one that says voltage, and I'm going to wire it up to voltage. I'm going to drag this down a little bit. And if you right click on the wire, you can clean up the wire. Sometimes it rearranges it nicer. So there we go. That looks like the most basic thing, one channel voltage. But you look up here and there's a broken arrow, which is an error. If you click on it, it'll show you the errors. Required input links resource is not wired. If you click on this, it will show you there's something missing here. So if you look at examples, there are lots of examples on how to use links. What you have to do is you have to open the device. You have to, LabView has to take control of the Arduino. So it has to open it at the beginning and it has to close it at the end. So I'm going to add here from that same links toolbox, Maker Hub, links, open. And I'll put it here on the left because everything starts on the left and flows to the right is the convention. And I'm also going to put the close, Maker Hub, links, close, because if you don't close it, it will work once and then it gets bad. So I'll show you what happens, but make sure you close it or you end up having to restart things a lot of times. So this is a serial device, which is what our Arduino is. There are other kinds of links devices. And what we have up at the top here is this links resource, and that was what was missing. So I can connect it over here. And we still have an error. Links resource not wired. Oh, and then that one over here. So it chains through, so we can take that resource out of the analog read and plug it into here. So now this will open it, pass the handle, the way to access it, to this so it can read, and then when this is done it will say you can close, I'm all done. So we need that chain of open, read, close, or else things crash or don't work. So once we have that connected up, it's okay, but we have to give it some more information. We have to tell it which serial port. That's always important with Arduinos because they come up with different numbers. So the serial port input is here, and we could run a number in or the COM port name. There are strange data types, so this is going to be something that LabView knows how to name it properly. And so the easiest way is if you right-click over that serial port line to create constant. If you want it to be on the block diagram, will be here, and then you can choose the serial port so it looks in your computer and what serial ports are there. I want it to be on the front panel so my user can do it. So instead of create constant, I'll right click and do create control. We'll use this all semester, so remember that right click and create control, because it finds the right kind of thing to connect. So it needs a serial port, and it found a serial port picker tool. So that's great. The one other thing, now we know which Arduino to talk to, but there are 6 analog inputs on the Arduino, so we need to tell it which channel. So that's the analog channel here, and I'm going to do the same thing. Right click, create control. See, this is just a number, so I could have put a numerical control on the front panel and wired it up myself. But I'm gonna try to keep all my setup things here on the left. And I'll use cleanup wire all the time. And my output's over here on the right. Okay, so it knows which Arduino to talk to. It knows which channel on the Arduino, has a place to send the voltage, and it cleans up when it's done. So I think that's enough. I'll tidy up my front panel, put this up here. I'm going to choose COM11, because that's what it is. I looked in the device manager, and analog 0 is correct. I've got my Arduino set up here. So hopefully you can see my potentiometer set somewhere in the middle, and it's wired up like we saw in that other video. Hopefully that doesn't look terrible. If it does, I'll edit it out. So I'm going to press run and see what happens. Hey, 1.56. Sounds pretty good. I'm going to turn the knob, run it again. 2.48. It's looking good. So if you get there, you should save this in case it crashes. And then this is a good one to go back to if you're ever having trouble with analog inputs, because it's the most basic thing. It's nice to have test cases you can do one read on that voltage and save it. If you forgot this close, or if other things happen and it crashes, you'll see sometimes if I open this COM11, see this COM10 with this little indicator by it. I was playing around and I didn't put the close, and my Arduino was on COM10, and this little symbol means that LabView thinks it's an instrument that it can talk to on COM10, even though right now there isn't anything on COM10. When you see that little sign, that means linx won't be able to access it because LabView has it and won't let it go. It didn't close properly. It's still it's trying to talk to it still in the background. And this has been really frustrating for me because I don't know a great way to close this. I think we can make a VI that searches for all open and closes them all, but I haven't done that yet. Anyway, it seems to be if you unplug your Arduino and shut down all the LabView windows and maybe reboot your computer, what happened then was it still shows COM10, but my Arduino came back on COM11 and I can carry on. So this is still hung somewhere in the background, but I've abandoned it for now. So if I find a better solution, I'll let you know. But if you see that, it's probably not going to work. So look out for that. This little, looks like a little instrument, and it means that it thinks it's there and it's still trying to talk to it. So if you know how to fix that, put it in the comments, as they say on YouTube, or just let me know. Okay, so I think that hopefully that's all the troubleshooting you will need. Make sure that you're connecting up to the right things, serial port to serial port. We have these baud rate override, error in. Actually, we can do the errors. Let's do a nice thing with the errors. Right now, if we get an error of any kind, if something doesn't work, it just pops up and crashes the program. You can do a little bit nicer job. Click way down here under, it's not under structures. Dialog and user interface, there it is. So there are different error handlers. The simple one is the one that I like. And I'll put it over here at the end next to the close. And then you can see the way errors work in LabView. Anything that can generate an error can also receive errors from other things, and so you chain them all together. So this error is the beginning. There's no errors over here. So this, if this sends an error, it will send the error to this block, and if this or this get an error, now it will come out here. And so now any errors are coming into here, and I can run them error out into error in, and this will display a little message with the error. It handles it a little cleaner. There are other nicer error handlers, but this one is good enough for us, because basically if it crashes, we just have to fix it. Make sure that still works. Looks like it did. I'm going to turn the knob, and we'll watch the voltage change. Looks good. If I run it continuously, this opening up and closing down every time slows it down, so it doesn't respond very fast, but I can turn the knob and you can see it's getting something. So it changes slowly. And we'll fix that with a loop in the next video. But right now we've got a nice single sample system. It's great for testing it out. So save this, clean up your wires, and put that in your report. All right, I will stop here.